So today we're going to talk about parametric equations and plane curves. So the question probably should be in your head is what is a parametric equation? All right. So what a parametric equation is another type of curve that introduces a third variable. All right. Normally, like for example, time. So if you want to find out, and I'll draw maybe a little picture here, and I'm going to attach a video from Khan Academy. And I think he explains that really, really well. Like if you have some kind of car that's just falling off, right? It looks like, and you want to know that path that it takes, right? And say that this is y and this is x, right? We can use a parametric equation, right, where it tells us the position in the x direction, the position in the y direction at any time as that car falls off a cliff. Okay, so that's what we need. So we introduce a third parameter, right, and that parameter is what we call this parametric equations, because now you have a, in this case, the example that I just gave, you have a parameter that has to do with time. So we're gonna quickly just show you what that means, all right? So let's say we have a parametric equation that is defined by x is equal to t squared and y is equal to t cubed minus 3t. And we want to, this is how you would graph it. Okay. For all you're doing really is just plugging in a -2 here. For example, for the first one, if you plug in a -2 there, you're going to get 4. And then you're going to get, if I plug in that -2 in here, I would get a -2. All right. So that's all I'm doing. And as I go down the line and I plug in all of these values in here, um, this will give you 0. So basically, if you just go down the line and plug everything into this parametric equations, right? Now, when I put these points, you're going to really not think there's anything different here. But there is one main difference when you graph a parametric equation, right? So I'm going to plot those points that we have here. So uh, let me go with red here. So I'm going to plug in, let's see, 4, -2, which is right here, 3, 0, 1, 2, and then we have 0, 0. Okay. And then we have 1, -2, and then 3, 0 again, and then 4, 2. All right, so notice that the order in which I did this, right, I'm just writing about the order, is I did this one first, and then this one second, this one third, this one fourth, this one fifth, this one sixth, and then this one seven. Right now, I don't write those numbers. I'm just showing you the order of which I did, because now what I'm going to do here is when I connect all those dots, right, I have to go in the order that I started. I have to start with the first point that I plotted, and then I'll go this way, and then that way, and around this way. Now, when we graph a parametric equation, all right, we normally don't write these numbers like 1, 2, and I don't know why that's not erasing here. We normally don't write these numbers, but what we do draw on here, all right, is we draw the direction in which this parametric or this particular, I don't know if this is a particle or whatever it may be, was heading, right? So we started from here, we went that way, we went that way. And what I'm doing here, by the way, guys, this is not really an option, right? So when we graph a parametric equation, you have to show me the direction of where it was going, all right? You have to show me where you started it and what the direction of this parametric equation, that this parametric equation took. Okay, so let's now go to example 2. All right, and this one we want to change the following to a rectangular form by eliminating the parameters. So our job here is to do some algebra to get rid of the parameter, essentially, right? Which in this case is t. I was going to call t time, but that's not necessarily true. So let's see. We can cross multiply this if you like. Let me go back to black here, and then we would have something like this, or multiply with substance in the denominator, right? And again, I'm going to try to get rid of the value of t, and you're going to see how, right? Essentially what I'm doing is I'm going to solve for t. All right, so now to solve for t, I'm going to divide by x and then square both sides. All right, so I'm going to go ahead and do that in one step. I'm going to divide by x and square. Now, if I square the 1, if I square that 1, it's still 1. So I'm going to just do it like that. All right, so now that I've squared both sides, I'm just going to subtract 1. So I have t is equal to 1 over x squared minus 1. And then, because of what I'm about to do here in a minute, I'm going to go ahead and find a common denominator and write this as one single fraction. So I have 1 minus x squared, again, if I find a common denominator here. And this is what I'd end up there. All right, so now on the other side, I'm going to do the same thing to, well, actually, I'm going to use this y function. So I guess you could do it either way, but on this y function, I'm going to plug in, I'm going to replace this t that I have on y with what I just found, which is 1 over x squared all over t plus 1. But remember, I'm replacing t with what I just found here. All right, so again, I just replace all the t's on the y variable, on the y function, with 1 minus x squared over x squared. So plus 1. All right, so let's see. What we're going to do here now is, it would be nice if the bottom of that fraction, that bottom part, would be one single fraction. It would make it a lot easier, right? So what I can do here is I can multiply this top and bottom by x squared to find a common denominator. And when I do, that would leave me with 1 minus x squared over x squared. Now that's the top part, all right? Now, well, I don't really know how many steps I have to write on here, but essentially I have 1 minus x squared plus x squared all over x squared. All right, so basically I just rewrote that in a slightly different way. Notice that the x squares are going to cancel. All right, and if I keep changing, let me go back to black. If I keep changing flip, the x squares are also going to cancel here. All right, so I end up with y is equal to 1 minus x squared. So again, my final answer here will be y is equal to 1 minus x squared. Now, when we graph this, okay, it looks something kind of, it looks like it's a parabola, right? Upside down, up 1. That's not super difficult. And the next point would be like 2, -4, but I'm not going to be able to graph that, so I'm just going to keep going that way. Okay, so that looks like a terrible parabola. Let me erase this to a little bit here. All right, so it doesn't really to write it to kind of graph it as a parametric equation. And the only reason I graphed only half of it is because I went back and used my calculator, and I put this as y1 and y2 essentially, and I just went and started plugging in points for t, as long as t was greater than -1. And it turns out that if it did not need to know direction, right, it's actually going this way, oddly enough. All right, so turn the page here. Just actually going the opposite direction of what I thought it would go. And basically, the closer and closer I get to -1, y goes to 1 and x goes to 0, but it quite doesn't make it there. So I guess I should probably put some kind of open hole there. But that's what it would look like. All right, so now we're going to do the same thing. All right, we're going to try to limit the parameter, but now we have some kind of trig function. This is going to work slightly different. And it's probably something that you may or may not have done in the past, but this is how we're going to do it, right? So essentially, I will try to get the cosine of theta by itself. So this time, we don't have theta as a t as a parameter. We have theta as the parameter. All right, so I'm going to divide both sides by 4. That's going to leave me with cosine of theta. If I do the same thing over here, if I divide both sides by 3, I get y over 3 equal to sine theta. Now, we both know, hopefully, that if the cosine square, this is kind of a side note, so I don't just write it and you don't know where I got this from. We know that this is true. Okay, so we know that cosine squared plus sine squared equals theta. So, okay. So the way I can write this is I can actually square this. And if I replace the cosine square with x squared over 16, and the sine square with y squared over 9, all right, this should still be equal to 1. So you may not recognize this, but this is actually the equation of an ellipse. Now, some of you might have done this in Algebra 2, some of you may not, right? But essentially what that means is that the point on the bottom here, or this number on the bottom, the square root of that would be essentially like the radius, in this case, of the major axes, right? So, and then the y, if I take this 9 and I take the square root, I would have this as the minor axes. Now, when I connect all of this, all right, this is the equation of an ellipse. And I'll attach a video also about an ellipse because I don't really want to waste too much time talking about it. But that's really all you have to know about an ellipse. That is a terrible looking ellipse on my part. My bad. It's supposed to look kind of smooth, not so crappy like I just made it look. All right, so this is an ellipse. And so we're basically done with that. Okay, so again, I guess that's all you have to know. So we're going to go ahead and move on. Now, when we're finding parametric equations, this is just another stuff right here, right? So the easiest way to do this is to let x is equal to t, and then represent the y as a function of t. So this is our equation right here, and we want to use the following parameters. So we want to rewrite this. Now, the first one's going to be really easy because all I have to do is replace this x with a t, and I'm done. All right, so this is going to be t squared. Whoop, didn't mean to do that. What's happening here? All right, my apologies. Stop it. All right, so that's it for that. On the other hand, though, on this one, I want to replace this x with some other variable, but this is going to be not as easy, right? So what I'm going to have to do here is I have to take the derivative of the function. So in this case, m is going to be the derivative of this, which is 2x. Now, that's the x I have to replace, right? So what I'm going to do now is I want to replace this x with some kind of m. But to do that, I'm going to have to solve for x here. So x is equal to m over negative 2. And then I'm going to plug that in into that equation. So I have y is equal to 2 minus m over negative 2 squared. So I have y is equal to 2 minus m squared over 4. So that's pretty much it. All right, that's the answer. So in this case, that's what I get. That's all. All right, so now we're going to talk about how to the parametrization. That's a hard one to say. I didn't even realize it was hard to say until I said it out loud. Of a line. All right, so if they give you a single point and a slope, you're going to use these two formulas here. All right, if they give you 2 points, then you're going to use this two formulas. And I'll explain what all of this S and R and all that stuff. S and R are just the slopes of those parametric functions. And but I'll show you how to use it. All right, so let's go to example 5. So in example 5, right, they give me a point and they give me the slope, right? So essentially, I'm going to use the first set of functions here. I would probably go ahead and start by, let's see, it says it here. So notice the, okay, notice that right here, they tell me that the slope is equal to S over R. All right, so I'm going to use that information to say that S over R is equal to 4, right? So my slope is equal to S over R. Now, I know that this is 4, and I can write it as 4 over 1. So therefore, this means that S is 4 and R is 1. And now I can very easily convert this. I can do the parametric equation of these lines, right? So X is going to be equal to, let's see, A would be this point and B would be that point. So this would be 3 plus RT. Now in this case, R is 1, all right? We just know that. So I'm just going to write 3 plus T. For the Y, B is -2 and S is 4. So this is the other parametric equation. All right, it doesn't really ask me to graph, but if I had to, right, with that point, 3, 1, 2, 3, -2. If I would pick any other point on here, with a slope of 4, so 1, 2, 3. In this case, this line is going that way. And you can kind of use the parametric equations to figure that out. Like if you plug in 0 for t, you'll find out that you start right at 3, -2. If you plug in 1, then you'll see that you're going up and to the right. Okay, so that's the direction that this is taking. All right, so what if you have 2 points? All right, so if you have 2 points, again, I have to use those functions above, and this is going to be AB, and this is going to be CD. Okay, and I'm going to write the functions here, or the formulas, I should say. A plus T C minus A B plus T C minus D minus B. Okay. So now, let's see, X is equal to, X is equal to 2 plus T C minus A would be 4 minus 2. So 4 minus 2 is 2, so this is going to be 2T. And that's it for that side. Now over here, B would be -6 plus T. And then D minus B would be -3 minus a -6, which is going to make that a +6. So this would be Y is equal to -6 plus 3T. And that's it for that. And again, if you wanted to graph it, you could write those 2 points. 2 -6, I don't know, 2 -6 would say it's somewhere over here, and 4 -3. 4 -3 say is somewhere down here. And if you just plug some points into the parametric equation, you would see that the direction of the parametric equation would be like that. It'd be going out to the, it'd be going up and to the right. Okay, so now on this technology skills, all right, I can't really show you this part. Okay, so you can kind of do this example if you want to, but what we can do is they tell you the keystrokes for the TI graphing. All right, and in your case for the TI 84. If you're an Inspire, you can just follow what it says in the Inspire for. But for some of you guys, all I have to say is I did this myself. Is that it's talking about on the graph screen, so you have to press y equals, right? And then you go. Let me turn on my calculator here, even though you can't see it. And then you have to go to mode, and if you notice the fourth option from the top, it'll say function PAR, which stands for parametric, polar, and I'm guessing that's sequential. I never use SEQ, but all right, you're gonna go to the second option, which is PAR, which is parametric, and press enter. And then after that, right, it says T max is equal to 20. You're gonna notice that automatically if you just basically go to the parametric mode. When you go to y equals, right, and put this as x1 and y1, you're gonna notice that when you go to y equals, it'll actually say x1, y1 with a t beside it. So again, please try it out. This will make a whole lot more sense if you do it. And then when you press your variable button, it will no longer put an x. It will actually put a t. And as far as this t max, you'll see what that is. Also, if you go to the window, right? If you look at the window, the first two options will say T min and T max. All right, so set your T max to 20, and then you have your X min and X max here, and then your Y min and Y max. Now notice that this goes all the way to 6 pi here, so that's somewhere around 18 point something, between 18 and 19. So if you graph it, okay, and I'm gonna try to do my best to graph this. This is a pretty crazy looking equation here. Let me see. Where did I put that calculator? Oh, there it is. I already have it drawn here, but again, I'm going to do my best to draw it. But again, I really do encourage you to do this. It's pretty weird. Let's see. I think I can go above 4. So I kind of start here, and then I go close to 4. I gotta put some points down here, boys. This is difficult. Okay, let me start over on that. I'm gonna make it all the way over here. Get a little crazy here at the end. But I hate it when it does that. Alright, so that's sort of what it looks like, right? So really, please go to your calculator and just basically do what it says on the back of this paper and see if you can graph this. You shouldn't have any problems. But if you do, just let me know and we'll figure it out.